Okay, so let's go through Cedar's remaining MCQs. Okay, so we'll go through only the selected questions where you guys have gotten wrong. So question 27. Okay, so question 27 is testing you about light. Okay, so two formulas that you need to use. First formula is your n equals to sine I over sine r. Okay, and then equals to c over v. C is the speed of light in a vacuum. V is speed of light in a medium. Okay, so you sub in all the value. Okay, so one thing to take note, so your angle of incidence, right, is always, remember, always measured from the normal. Okay, so please go and draw your normal. You'll notice that it's 40 degrees. Okay, so if you do the calculation right, you should get the angle of refraction that will be 26.3 over here. But is that the final answer? No, it's not the final answer. Okay, and I think this is where majority of you will get stuck. The question is asking you how much does the light rate deviate. Okay, this is the key thing the question is asking you. How much does the light rate deviate? Okay, means, okay, so as you can see now here, right, I have drawn the original ray in red. Okay, this is if there is no refraction. That's the original ray. So how much does the light ray deviate, right? Is basically asking you what is the change in the angle if it doesn't refract. So to get that, right, what we need to do is, originally, right, it is only 40 degrees. So how do we get the final answer? It will deviate by 40 degrees minus 26.3 degrees equals to 13.7. Because we're trying to find this angle over here, the angle in red. Okay? For second question, question 28. Okay? Question 28, if you really forget, okay, this is a pure memorization question. If it's at below, if it's within F, right? If it's within F, what would it mean? Within 0, between the lens and F, it will mean that the object is behind. Behind. It's not past the lens, it's behind the object, right? And it's virtual. This is when some of your object will look like that, right? That's for D. Okay? For C, is exactly at F, at the focal point at F. What does that mean? It means that it's the same shape and the same distance also and the same height. It's just saying it on the opposite direction like that, right? And I've drawn B for you. So B is all the lines in blue. So that will be, as you can see, compared, this is the image of B, right? This is the image of B. And you can see that the image of B is definitely much larger, it's magnified, right? Between F and 2F, this is magnified. And for A, right, you can see A, the image of A is in green, and it's much smaller, right, than the object. So in exam, how do you know? Let's say I forget all these things, how do I go forward in exam? Okay, one thing very good in exam is you can draw to scale. So what do I mean? So down here, if the length of the focal length down here is, you measure, okay, it is the same as the length over here. Okay, and then you can draw the two, and then after that you can proceed with drawing, right? Because you know the first ray always goes through the center, then the next ray goes through parallel, and then goes through the focal point. Okay, so if you don't know, then just try and error in the actual exam. Okay, but I hope you just memorize. 30 is a definition question. Okay, electric field at that point just means the direction of force on a negative charge. Remember, electric fields are electrons. Okay, I'm not going to go through this. Yes. Okay. For this, okay, you need to know the formula R equals to PL over A. Okay, R equals to PL over A. This is very important. Okay, and what rho L over A? Rho is referring to the resistivity, and is affected by the material. We know that the material is the same, so there is no change in material. And okay, why is this formula so helpful? Because we know that L is referring to the length. When length increase, the resistance increase. When the area decrease, the cross-sectional area decrease, the resistance increase, because they are inversely proportionate. So if we compare A, B, C, D, okay, we notice that B has the highest resistance of 2R, right? and C is the high and lowest resistance of 1 over 2R. I think majority of y'all can get here. Now, the next point of question is, I think some of y'all will use I square R. Okay, why we cannot use I square R in this case? Because in this case, what happens? Does the current change? The current changes. The current changes. So we cannot use I square R. However, because we're given in the question that the lamps are connected in a parallel manner, means what? The voltage is constant. Why? Because it's directly connected to the battery. So the voltage does not change. So by applying V squared, we know P equals to IV. Using V equals IR, we can get V squared over R. And based off that, you know that you want the lowest resistance. Why? Because the lowest resistance will give me the most power. So when we look at the thing, most heat and light per second, we are looking at the power over here. Okay, and then with that you can get the answer C. Okay, moving. So for question 34, okay, this one, okay, there's two ways of doing it. I just did it by the shortcut way. So went to calculate the power of the aircon, which are given in the exam, 2.5 kilowatts. Okay, then you're also given 2 ceiling fans. Remember to times 2 for this, okay? And careful, the units here, it is 100 watts. So it is 0.1 kilowatts. So with that, you times 2 is 0.2 kilowatts. So they just asked me, what is the additional cost? Okay, additional cost, and remember down here, it's not per day, it's per week. Okay, it's per week. So you not only need to times 8 hours daily from over here, you need to times 7 days or so. Okay, so with that you can get the answer. Okay, I think the careless mistake here is per week and not per day. Even then you cannot get all the answers. Okay, next one, 35. Okay, so what is the main thing for 35? 35 is, which of the following will cause the needle of the compass to point closer to the magnetic north? You already know that the compass over here points directly to the north automatically. So what is the goal of this experiment? The goal of this experiment, if I want to point it as close as possible to the magnetic north, means I want no additional magnetic fields affecting the natural pointing of the compass. Means, and you know that down here you are given a solenoid, right? You're given a coil, right? And the coil has a magnetic field, right? I've drawn for you over here the magnetic field. Use right hand grip rule to determine which side is going, right? So the right hand grip rule will show me that it's pointing in the opposite direction. So how? I want it to affect it as least as possible, right? I want this solenoid to not affect it at all. So how do I make a solenoid not affect it at all? Is I make it a useless solenoid. So what is the best way to make it a useless solenoid? Is to decrease the current so that the magnetic field will be less strong. And because of that, then it will affect the compass less. And the compass will just point directly to the magnetic north. Okay, Ken? 36. Okay, this question is a Lenz's law question. Okay, Lenz's law. Remember Lenz's law? Lenz's law means the induced current flows in the direction that basically opposes the direction of the motion. So where is the wire moving? The wire is moving up. The wire is moving up. But Lenz's law tells me that I don't want the wire to move up. So I want the wire to move down. Okay, so with that, and because of that, because of Lenz's law, I know the force will be downwards. Okay, so force will be downwards. So because I know the force is downwards, what's the next thing I can do? I can use Fleming's right hand rule, right? Magnetic field is, okay, so if you put up the fingers, I cannot show you, but your force will be downwards, so the thumb to the floor. Remember, using your right hand, your magnetic field is to the right. This is your middle finger, remember? And your index will point towards the page, into the page. That means it's from X to Y. Okay? Question 40. Okay, this one. Just go and memorize the answer. Okay, I've drawn a small diagram over here. So this one is, I think it's quite easy to remember. Alpha particles cannot pass through the thin sheet of paper. Okay, so I've drawn it clearly for you. Aluminium foil can pass through the thin sheet of paper but cannot pass through the aluminium foil, so they get stopped there. Gamma rays can pass through thin sheet of paper and aluminium foil, but they cannot pass through the concrete LED. Okay? So with that, we have come to the end. Okay? All the best to your prelims. Keep working hard. Okay? And 加油. Okay, bye-bye.